Okay, so for our project we did 10.4 hyperbolas, and to explain it further we have some drawings. So right here you can see where the focus is, and over here this is a better drawing where you can see the vertex at each point and then the foci on the outside. And here's the center in the middle. And the distance between the center to the vertex is A, and from the center to the foci is C. And down here we have some equations that can help you decide what you need to use for a certain graph. So if the transverse axis is horizontal, like in this picture, you would use this equation. If the transverse axis is vertical, like in this picture, you then use this equation. And if the center is at the origin, you would use a shortened version of the equations right here for horizontal and right here for vertical. And remember, for hyperbolas in this unit, you need to use c squared equals a squared plus b squared. Okay, so for example 1, it's finding standard equation of a hyperbola. And what we're given are the vertices, which are 0 plus or minus 2, and the foci, which is 0 plus or minus 4. And what's easiest with these kind of problems is even if you want to graph it out, and you can see where it is on a graph. So we're just going to draw a quick graph here. And you can go up 2 for the vertices, and then up 4 for the foci. So, and then you can conclude that the graph is going to kind of go something like that. And from this information, we can see that from the center up to the vertice is the A value, which is 2. And from the center up to the foci is the C value, which is 4. So A equals 2 and C equals 4. And remember, for these kind of problems, you want to keep in mind that c squared equals a squared plus b squared. So with this in mind, we can then do c squared equals 2 squared plus b squared. So 16 equals 4 plus b squared. Then we subtract 4 to get 12, which equals b squared. And we can just leave it like that because when we're going to put it in our equation, it works out being okay. So with this in mind, because the graph is going vertically, vertical transversal axis, transverse axis, which is vertical, my bad, we can then do the equation, and because the center is at the origin, we can write the equation out as y squared over your so then we come to our equation, which is y squared over a squared and x squared over b squared, which equals 1.
Sketch the hyperbola as well as find the center, vertices, and foci. So for here, the equation is x plus 3 squared over 144 minus y minus 2 squared over 25 equals 1. So you know here the center, you're going to look at these two values for that. So already you can say the center is going to be negative 3, 2. So we can start our graph down here. My apologies for how non-straight this line is. Okay, so we go over negative 3, 1, 2, 3, up to, this is going to be your center here. So the next thing that we can do is look at these values here, which is going to be your a squared value and your b squared value. So a squared equals 144 and b squared equals 25, sorry. So then if you take the square root of each, a is going to equal 12 and b is going to equal 5. And so in hyperbolas, the a squared value is always going to be in this first position. So because the x is over the a, you're going to know that it's going to be a horizontal graph because x is the x like that like line, and then y is vertical. So you know this is going to be a horizontal graph. So then to graph the vertices, you know that the a value is on the transverse. So if you take the center and move it over 12 spots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is going to be one of your vertices and do the same. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This will be your other vertice. And then you can just look at the graph and be like 1, 2, 3, 4, 5, 6, 7, 8, 9, up to. So you know that one of your, oh, I definitely spelled that wrong. Awkward. So one of your vertices is going to be 9, 2, and take the same 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, up to, and your other vertice will be negative 15, 2. And then you have to find your foci. So by doing that, you have your a squared value and your b squared value, and using that same equation, c squared equals a squared plus b squared. C squared is going to equal 144 plus 25. C squared equals 169. Take the square root of both, and c equals 13, which is easy because a is 12. So, I mean, if you count it out again from your center, it'll be 13 spots over, which is right here, and 13 spots over this way, which is right here. So then you can write that at a specific point that your foci is going to be 10, 2, if you look at the graph, and negative 16, 2 are your two foci. So now in order to draw the actual, like, I don't know what you call this, the hyperbola, yeah, I guess that would make sense. You can draw the box. So looking at the b equals 5, so this is going to be your, like, smaller axis here. So if you go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, you can make a box with your vertices and that b value. And then once you make your box, you can draw a diagonal from the center to the corners. That was a big miss. It's okay. And your asymptotes are going to follow this diagonal. So this will be the shape of your hyperbola. Oh, that is a foci. JK, erase that part. And then you got your center, vertices, foci, and your hyperbola with the asymptotes.
Bingo.
Okay, so now we're going to classify conics and specifically hyperbolas. So basically, you know that a equation is a hyperbola when there is both an x squared and a y squared. However, these x squared and y squared have to be subtracted from each other because that's what makes these two sort of like parabolas go away from each other rather than be connected like a circle or a ellipse would. And there also has to be an x and a y in there, but it doesn't matter if those are added together or if they're subtracted. And that's basically it.
Hyperbolas is classifying. So when you get an equation like this, you're going to have to figure out, is it a hyperbola, is it like a circle, and all those different equations. So to start off, you need to rearrange this so that the x's are next to each other and the y's are next to each other. So I'm going to rewrite this as 9x squared plus 36x minus y squared plus 10y plus 2 equals 0. And then the next step is to get the 2 onto the other side. So I'll rewrite it again. And then subtract 2, so it'll be equals negative 2. And then the next step, you're going to have to complete the square here. So you're going to take the 9 and take that out, so it'll be 9x squared plus 4x, because 36 divided by 9 is 4. And then you're going to leave a blank here. And then it'll be minus y squared. And then you have to be careful here because it's a plus 10, so you have to go minus 10y here, so that when you multiply it out, it's plus 10. Leave a blank, equals negative 2. and then here's where you complete the square. So you're going to take this middle number here and divide it by 2, and then square it. So 4 divided by 2 is 2 squared equals 4. And do the same thing here. Negative 10 divided by 2 is negative 5 squared is 25. But whatever you do to this side, you have to do to the other side. But you can't just add a plus 4 because really it's 4 times 9. So really you have to add 36. And then the same thing here would be subtract 25 because of the subtraction sign right there. So if you simplify that out, it'll be keeping these exact same things the same here. And negative 2 plus 36 minus 25 equals 9. Okay, and then the next step here is to factor out this equation. So, you know, what equals, or what multiplies equal 4 and adds to equal 4 is going to be 2. So x plus 2, and then an x plus 2. And then this right here, what adds to equal 10 and multiplies to equal 5 is going to be negative 5. So y minus 5 times y minus 5 equals 9. And then you can simplify these as writing it as 9x plus 2 squared minus y minus 5 squared equals 9. Now, what do you know about hyperbolic equations? That it always equals 1. So to get this to equal 1, you have to divide this side by 9 and divide this side by 9. So 9 divided by 9 is 1, so it's going to be x plus 2 squared over here over 1 minus y minus 5 squared over 9 equals 1. And this right here is your equation, so you know it is a hyperbola because of this subtraction sign here, and you know it'll be horizontal because the x value is first.
Bingo.